So next, we are going to look at the single phase generator, okay? How to use the digital multimeter to troubleshoot your single phase generator. So when you look at the single phase generator, it is somewhat different, okay, from what we have in the three-phase generator, but all the major parts, they are also present because this is the main feed on the router, okay, and this is the armature, okay, on the stator of the generator. Then we also have the exciter winding here, okay. Then on the terminal block, you have your rectifier or your AVR that supplies this main feed via, okay, these are the terminals of the exciter winding, okay, exciter armature, okay. It's the same feed winding that induces voltage into the exciter armature. That is the main feed winding that induces voltage into the exciter armature, but it's a separate winding inside wound on this stator, okay. So the output is sent to your AVR or your rectifier, and then the output, the DC output from the rectifier is sent by this slip ring to the main feed. So as it's rotating, that will now magnetize the main feed. So as it's rotating, it will induce voltage on the main armature of the generator, and then you get your output, okay, to your where you can tie your load to. So these are slip rings. This slip ring, these two windings, if you look at it, you see that they are insulated from the ground or the rotor itself, the yoke of the rotor, okay? They don't have any business with the yoke of the rotor. So you can test to ground, continuity to ground, okay? Then this finish, this one, you can either connect the finish to finish or finish to start. So finish to finish and start to start, okay? So either the finish to finish, the finish lead from this winding and the finish lead from this winding, okay, is taken to these two terminals, okay? They are connected to the slip ring 1, slip ring 2. There are some too, they can connect them finish to start, okay? It depends on the generator configuration. So they are connected, the other two terminal that is supposed to come out, they are connected to these two slip ring. These two slip ring by design, they don't have any connection with each other. When you take your continuity, you take your probe, take your meter to the continuity section. When you probe these two, okay, put one here and the other here, you will not have any reading, okay. You read to ground, you will not have any reading, okay. But when you connect this winding to it, okay, the finish from this winding to here and then that from this winding to this, you see that when you read now, you'll be having the reading of all of these windings. Are we getting it? So now, that is how you test for here. That means you test for continuity of this winding and whether they are shorted to ground. And you also test the resistances of this winding. So if it is something that you have been doing before, you know their resistances before, you now compare it with what you know to ascertain that it has not shorted. Because if it is short, the winding is less than, sorry, the resistance is less than what you used to have or what was and what is supposed to be there normally. It means that there's a short within those windings, okay? So it is too with the exciter, with the main armatures and the exciter armature, okay? So you test for the resistance. You see they are insulated from the yoke. You test for short to ground, okay? And then you test for continuity, okay? So that is the test that you carry out on the single phase generator with your digital multimeter. So once you have coupled, okay, and you connect it to the engine and then you start it, you can now on the terminal block, you cannot test for the single phase AC voltage, which is supposed to be 220. So if you are not having 220 volts, okay, it means that something is wrong with the entire circuitry. So you can start with the AVR or the diode assembly that is external, that is outside. Okay, so you test the diode assembly. If it is not working, if it is bad, you can replace it. Or if it is an AVR, then you replace it. Okay, then on the outside too, you also have the terminals from this generator. So you can also test to ground, test for continuity. Okay, and then also test if you have that residual voltage on the main armature, which is about 5 volts. So still on the single phase generator, here we have the AV arrow, okay, the automatic voltage regulator. And here, this is the armature winding and the exciter winding. They are here as we said earlier. So when you look at this schematic, this is the main armature winding, okay? These are the big windings that you can see here, okay, on this generator, single phase generator stator. Then the armature winding, this is it, okay? They are the smaller set of wire. They are wound on top the main armature winding. And as we acknowledged earlier, this is the feed winding, okay? So if you look at the connection, you will see that the main armature, okay, 2 lead from the main armature is sent to the AV arrow, which is the sensing lead, okay? And this is the wire, this is the sensing lead that is supplying the AV arrow from the main armature, okay? It's only to sense the amount of voltage that is produced in the main armature to see if it is enough. So if it is not enough, it will adjust the amount of voltage that will be coming, DC voltage, that will be coming from the AV arrow, okay, from this terminal to the main field, okay, to raise the magnetization and thus the amount of voltage that will be induced in the generator, okay, the main armature. Now, if you also take the reverse case, that is when you have overproduction of voltage, overinduction of voltage in the armature, this sensing lead will also get that signal, okay, of the overproduction. That will now be sent to the voltage detection circuit of the AV arrow. So seeing it as an overproduction, it will reduce the amount of voltage that will now be sent to the main feed, which is this one now, okay? And if that one is reduced, that will reduce the magnetization of the main feed and thus reduce the amount of EMF or voltage that is induced in the main armature, okay? So at the end of the day, it will help to balance what or make what is induced or coming out from the main armature to be steady. So if you also look at it, you will see that 2 of the lead, the positive and the negative, the black, the red and the black, also comes from the AV arrow to the slip ring of your main feed. This is the main feed. These are the slip rings, 2 of the slip rings, and these are the representation of the 2 slip rings, okay? So they are fed directly from the AV arrow, and these are the 2 wires that go straight to the AV, from the AV arrow to the generator main field. So if you also look, you see another wire that is sent to from the excitation winding to the phases of the diode assembly in the AV arrow. Okay, so these wires that are represented here. They are sent to the phases of the diode assembly in the AVR. So this excitation winding, what it does is that it's wound on top the main armature winding. What it does is that it produces the excitation voltage, okay? The same magnetism that is produced in the main winding induces that excitation voltage into the excitation winding, and that is sent to the diode assembly in the AVR, okay? And that will be rectified, and then it will be regulated before it is sent to the main feed. So this is the main feed winding, as we said earlier. This is the main feed winding, as we said earlier, and this is the representation of the main feed. Okay, so this is how you connect the AVR to your single phase generator. So you see that the AVR is also a very important unit in the single phase generator. So how do you use the digital multimeter to test this? Remember, we have said that in testing this and testing this, you test for the continuity of each of the winding. You can test for the resistances, okay? And then test if it is short to ground or not. Those are the three tests that you can carry out when the equipment is dead. But when it is live, okay, you test the output. You test the output to ascertain that what is coming out is what is desired. Okay, so those are what you can do live. Then on the AVRO, knowing that these two terminals that goes to your exciter winding is from the positive, and okay, that goes to the exciter is from the phases, okay, of the diode assembly. And then the one that goes to your slip rings, these are the slip rings that goes to your slip ring in your main feed, okay? They are from the positive and the negative terminal of your diode assembly, okay? So what you can do when testing this AVR is that this cable, once you have been able to identify it, you see that when you put your red probe here, okay, and your black probe here, in the continuity selection or the diode test selection of your digital multimeter, you switch your selector, okay, to that section of your digital multimeter. Then place your red probe here and your black probe here. After disconnecting it from the slip ring, you will have reading. But if you reverse it, that is placing your red probe here and your black probe here, there won't be any reading, okay? The face to face, you still don't expect to have any reading at all on the face to face, okay? So that is how you can use the digital multimeter to test the exciter, the AVR of your generator, okay? So that is how you can use the digital multimeter to test the AVR of your generator. Like we said earlier, you have identified this to be the positive and the negative going to your, you have identified this to be the positive and the negative going to your main feed, okay? So when you place your red probe here, that is place your red probe here and your black probe here, you will have reading. But if you reverse it, you are not expected to have readings. If you have reading, it means that the diode assembly in the AVR is faulty, which is this, is faulty, okay? Then the face-to-face, you also don't expect to have reading. If you have reading on the face-to-face, which is this particular wire, it means that your diode is shorted somehow, okay? It means that your AVR is not functioning properly. So that is how we can use the digital multimeter to test both the that's all of the active units in the single phase generator.